The main purpose is finding out the optimal path for the destination because as IP is connectionless and unreliable, okay, routing helps to find the optimal path for the destination, and the device is router, okay, which is responsible for this. Okay, it will take the decision on this. So how and what that discussion we have started. So there are two concepts: IP forwarding, what you can see on the screen. Okay, so this way it will go to the reach to the destination. But all this traffic, as we are in the IP layer, is happening on the logical address. Okay, so interface or the device which is responsible for this particular communication recognizes the IP address which is routed. So there are two addresses. One is called as net ID, where part of the IP is 0. So that gives the information regarding the entire network, and host ID. Host ID is so host ID starts from 1 to 254, whereas net ID is 0 and 255 is broadcast. That we have discussed. One is again in some cases reserved for gateway. Okay, one is again reserved for gateway. It is conventional. Okay, that's why remaining all IPs are the host IPs. So every router will maintain the routing table where it will get the information regarding on which particular interface we need to deliver the packet. Okay, because that interface is connected to the destination. Otherwise, what we have discussed is the simple routing or basic routing is flooding. Okay, basic routing is flooding. So it will send the packet to all destinations. But this will create huge traffic. And whenever network size is very big, this will create chaos in the network because if all the machines start flooding the packets, okay, the traffic scenario becomes very much difficult. So that's why point to point delivery is very much essential. But whenever we want to do that, we need some intelligence. Okay, whereas particular packet will forwarded or routed to the particular port. Okay, for that it is taking the help of routing table. But how the routing table gets updated? What information is there in the routing table? Okay, and on that basis, how updated routing table every router will get? That information we have already discussed and finished. We'll just refresh that and we'll go on. So this is the typical scenario. On the basis of routing table entry, the router will send the packet to the particular port and ultimately it will reach to the destination. Here, very important role of TTL. Okay, very important role of TTL because TTL decides the life of the packet. Okay, otherwise, packet will get looped into the network and it will never get reached to the destination. To avoid this particular scenario, TTL field is used. Okay, so basic idea is TTL is decremented at every router. When TTL count becomes 0, packet get dropped. So TTL count is typically 32, 64, 128. So that many hops maximum that packet can travel. Okay, so within that hops, if it is not reaching to the destination, okay, the packet get dropped. Okay, and what you message you get is the request timeout. Okay. Sorry. This is what we have seen the interface between the data link layer and network layer. So here it will see the lookup and on the basis of lookup it will set the next hop. If at all packet is of own, not of own network, okay, not of own host, okay. And for lookup table, routing table will help. Okay, so on the basis of routing table, it will maintain that. So forwarding and enabled and disabled that we have seen. Then this is very important slide what we have discussed. Every packet when reaches to the router, what particular functionality router is carrying out. Okay. So here what we have seen is it will validate the header. For that it is using the header checksum. Okay, which is again in the IP only, because there is no error correction for the data, but at least to guarantee that packet is not going to the wrong destination, so destination addresses should be intact and all the headers field should be intact. That's why first it will check the header validation, so it will give the guarantee that all the fields in the header are intact. Then it will process the option, because option gives the more information regarding the routing. Strict routing, loose routing, static routing, all the informations are in the option, because IP header varies from 20 byte to 60 byte. 20 byte is the default header, 60 byte is the with optional header. So 40 byte option is there. In that, all this information is available. So it will process the option if any relevant information regarding the routing is there. Then passing the destination address, it will check in the lookup table. After that, it will decrement the TTL. That is very important part. If at all TTL count becomes 0, discard the packet. If not, it will perform the fragmentation. That also we have studied in detail. Okay, because MTU is the concept or term where it will decide how much maximum packet size can be allowed in that particular network. It is called as maximum transmission unit. Okay, if your packet contains more than that, it needs to be fragmented. Okay, it needs to convert into smaller size. That particular process is called as fragmentation. So it will fragment that particular packet. After the fragmentation, what happens is many fields in the IP header get changed, because MF, offset, and which other field? Total length, all these fields get changed, and because of that, the checksum also need to be calculated. So it will calculate the checksum and transmit the packet to the next hop. Okay, and there's one more last point, which is ICMP, that protocol we have to study. So it will send the ICMP packet if necessary. ICMP is again request and reply packets, okay, which are there for managing the network. So control managed protocol. Okay. Control managed protocol. ICMP and IGMP are again two protocols which are supporting IP. So all these functions are carried out by the router, and then only it will proceed to the next hop. Then what we have discussed is there are different protocols. RIP, Routing Information Protocol, open source pathfinding protocol. So one is using distance vector. Okay, distance vector is typically using the distance into account, and distance here measured in terms of hops. Okay, so how delivery of the packet is possible with minimum number of hops. Okay, that is distance vector. Link state is again, it is taking traffic into account. Okay, traffic into account. For that we have seen the different examples. And for interdomain, this is the intradomain. Intradomain means within the autonomous system. Interdomain is outside the autonomous system. It is using the protocol called as BGP, Border Gateway Protocol, which is typically for or using path vector concept, which is typically using path vector concept. Then regarding the distance vector, we have seen how the routing table gets updated. Okay, for that, one typical example. There is A, B, C, D, E are connected, and what you can see is every router is having the table, and the table is having updated entry. Okay, so here what last time we have discussed is from A to C there are different paths. One is this, another is this, and third is this. But if I count the weight on this, here what you can see is 8, 2 plus 4 plus 3, 9, and here 6. So this is the shortest path, this is the optimal path, and what you can see is entry here available is how this entry is updated. Okay, how this router will get this information. Okay, for that, every router is exchanging the routing table with its neighbor. Okay, and on that basis, it will update the table. But again, when to exchange the table? For that, we have discussed two methods. One is periodically, but again, deciding the period is the question, because if I take the period very large, what happens as the network scenario is dynamic, within that period many changes are occurring in the network. Okay, so that it will miss the changes. Okay, this is one case. If I keep the timing very small, unnecessary exchange of table takes place, and this will create the traffic. This will create the traffic. Now, to optimize this, to avoid this situation, another method which is typically called as trigger based. Another method is called as trigger based. Trigger is router will exchange the table whenever there is a change in the table. Okay, otherwise it will not exchange the table. Okay, whenever there is a change in the table, it will exchange the table. And that will solve the problem of deciding the optimal time. Up to this point, clear? Up to this point, clear? Because already we have discussed this, we are just refreshing. Okay. Now, initial stage is this. Okay, whereas A has decided B at distance 5, C at distance 2, D at distance 3, because all these are directly connected. All these are directly connected. But E is not visible. That's why here infinity is there. Okay. Look at the table for same D. Only A is directly connected. All three are not visible. Okay. For C, A, B, and E are connected. This is not visible. So initial table is this. Every router is checking who is my neighbor and what is the cost for this, and that table is available. Now from this table, how it will get this table? This is the interesting question. What this initial table is this, and what you can see is the final table is this, so that A can deliver the packet through C to E. So for this, they will share the routing table. They will share the routing table. Now what you can see is, this is the table received from C. It will compare the table with this table. Okay, so it will keep this entry 0. It will modify this entry to 5. Keep entry to this. D is 3, and E, it will compare that this is 4 and C is at 2, so it will put 6, and what you will get is this is modified table. So it will compare the table received from C and original table, and it will update the table. Now here question is, if at all cost is same, then router will keep the old entry, it will discard the new entry. Router will keep the old entry, it will discard the new entry. And if cost is less in the new entry, it will keep the new entry, discard the old entry. Okay. So on this basis, all the routers are exchanging the table and updating the table so that they have optimal path for the destination. Now here what we have seen is, smallest cost it will keep. If the next node entry is the same, the receiving node chooses the new row even though it's infinity, because it will find that particular additional node or router. Periodic update is there and triggered update is there. Periodic update disadvantage, deciding the timing. Timing small will create the traffic. Timing very large will lose the entries or miss the entries. So for that, trigger update is selected. So trigger update is when there is a change in the table, then only it will exchange the table. Whenever there is a change in the table, then only it will exchange the table. Okay, that will solve the problem of this deciding the time. Now, one interesting phenomena already we have seen, which is called as two-node instability. Interesting figure where this particular connection get disconnected here, and because of entry availability, these two nodes start exchanging the table. And within that period, there is no packet reaching to the X. So ultimately what happens, packet will move here only. A will send it to the B, B will send it to the A. Again A will send it to the B, B will send it to the A. It will never reach to the X because this path has disconnected. This particular problem is called as two-node instability. Now to solve this problem, got this point? I think last time we have discussed. Okay. To solve this typical problem, we are using concept called as split horizon is the one, and second, define the infinity. Whenever that count is reaches to the 16 or more, it will keep that entry as infinite. It will not update to the 18 or 22 or 32 or 64. So maximum hop entry here is 16. So when it reaches to the beyond 16, it will put that entry as infinite, so that it will find the path from other way. Okay, or it will say that it is not connected at all. And second split horizon is, instead of flooding the table, okay, sorry, important call was that. So split horizon is, instead of flooding the table, means instead of sending table to all the connected nodes, suppose this router is connected to this, and this. Normally what happens, this will exchange the table with all the routers. But whenever we say split horizon, if that router is A and this is B, this is C, this is D, this is E. So split horizon is, router will exchange the table with A, only entries with B, C and D, not with the E. Router will exchange the table with D, only entries with E, B and C, not entries with D. So here typically this will not exchange the table of A and B. Okay, and in the first case itself, it will solve the problem because we will not never exchange this table with A because this path is through A. So no question of updating the routing table. No question of updating the routing table. That will solve the problem. Got the point? This is called as split horizon. Whenever multiple routers are connected while exchanging the table, it will exchange the table except that particular node entry or that particular router entry. This is called as split horizon. Got the point? Okay, we will never send the table to the A. When it will send packet to the A. When it will send the packet to the A X entry is infinite. That means not connected. Okay, it will drop the packet. So looping get avoided. Looping get avoided. Here, if at all path is not there, how the packet will reach the destination? It will not reach. But because of this table exchange problem, there is a problem of looping. And what we are going to solve this looping problem. We are going to solve this looping problem. Okay. Now next, now your answer, Mansi. Now another problem which is called as three node instability. This is critical problem. Now same two node instability, you can extend it to the three node instability. Check the figure, then we'll discuss. Now A, B and C, they are connected. X is connected. So table in entry is X. Now it is disconnected. Now it is disconnected. So A will put the entry infinite. But because of this, it will update the entry. Because of this, it will update the entry. And looping gets started. So whenever this problem arises, there is possibility that unless and until this count reaches to the 16, problem will not get resolved. Okay, whenever this counter again reaches to the 16, it will put the entry infinite and then problem get resolved. Till that point, the packet get looped into the network. And that's why this three node instability is that way critical problem in the network. Critical problem in the network. Just check. If any difficulty, put it in the chat. Got the point? Now I'll move ahead. What are the different packet formats for this protocol? So this is intra-domain routing protocol RIP. We'll see what is exactly the message format. See the example. Now these interfaces are showing what network connected. These are all net IDs. These are all net IDs. So looking at the net ID, immediately you can see what should be the mask for this. Here default masks are used. That's why for class C, last is the 0. For the class B, Q are the 0. Again, this is the class E, last is the 0. So they are using default mask. So that's why this is the typical routing table for all these routers. If my masks are different, for class C, if I am using the mask 255, 0.0, then my this ID changes. This ID changes. But here, as they are using the default mask, all net IDs are same as their classes. Now what you can see here is the message format. Here network address is mentioned and cost is mentioned. Remaining all are zeros. Okay. So command, version, this is reserved field. Okay. Network address, distance. So it will exchanging that particular message. So this is the request for particular address, and if this 0, request for all. Network address is mentioned, that is request for some. Network address is not mentioned, that is request for all. So if you capture the packet in the Wireshark, immediately you will get this information, where this particular packet is unicasted or broadcasted. Here request can be about specific entry or all entries. If specific entry, it will use this. If all entry, it will use this. And responses either solicited or unsolicited. And if at all periodic, it is 30 seconds. And if at all triggered, whenever there is a change. So that depends upon how the table exchange method is defined. If at all it is periodic, for the periodic implementation was simple, but you cannot restrict the traffic. You don't have control on the traffic. If at all network scenario is most dynamic, changes are occurring very fast, and because of that, table entries are changing. But if network is not that way dynamic, changes are not occurring frequently, in that case, the table exchange requires more time. Okay, so this is called as adaptive. Whenever there is a change, only at that point exchange the tables. Example we will discuss later at the time of tutorial. Very simple examples are there. Then it is using timers. RIP using timers. One is called as periodic, where that period is between 25 seconds to 35 seconds. Expiration timer. Within 180 seconds, if nothing is happening, it will discard this. This is the expiration timer. And garbage collection is 120 seconds. So whenever RIP is there, all these three timers are functioning. Okay, because periodic is required whenever I want to exchange the table. Expiration is how much time I should keep this entry as it is, and garbage is again another. So it will check whether it is if any valuable or valid entries in that particular table or not. So this is using timers for implementation, or what we call it as to make the changes. So 20 to 30 seconds is regular update time. So if at all implemented, it's periodic. Expiration timer gives the validity of route. So after 180 seconds, if nothing is there, it will discard that. And garbage collection timer. Invalid route is not purged from the routing table until the timer expires. So 120 seconds. So all these three helps for routing table entries. Otherwise, if there is nothing is happening and how much time I should keep this. So for that, expiration timer will help. When to exchange, periodic timer will help. And garbage collection timer is, if at all something is purged, invalid route is not purged, but after timer expire, it will purge that. So what you can see, 20 entries and 5 routes and 200 seconds it will keep. So total 21 timers are listed, one periodic timer. Expiration timer as 5 routes are there, total 20 entries, 15 expiration timers, and garbage collection 5. Now new version of RIP. Here what you can see is network address, subnet mask, next hop address and distance. All these entries are there. Okay. And authentication is 16 byte. Authentication is 16 byte. Nobody will ask you regarding the RIP message and other, but at least you must have the information how the table exchange takes place, what different entries are exchanged. So RIP version 2 and RIP version 1. So authentication is there in the version 2 and multicasting is supporting. V1 is broadcasting, V2 is multicasting. Now this is we have to discuss in detail next time, which is using port number 520 and protocol UDP. So if you capture the packet of RIP, the protocol field is filled by UDP and the port number is 520. So that we'll see at the time of tutorial how this RIP, ICMP, ARP, IGMP packets are there in the network and how to recognize this, what information you can gather with this. What information you can gather with this. Now link state routing finishing is not possible within this time. Just what you can see is, you can see the figure so that you can understand this. This algorithm is well known that you can do on your own. If list is empty and yes, it will come out of the table. Otherwise it will move in the table. So finishing this is not possible within 5 minutes. If any point remaining, I will just check and we'll finish that within 5 minutes. Okay, two protocols are remaining. One is BGP, Border Gateway Protocol, that we'll discuss next time. Okay, because if I start immediately, I think 50 minutes is already over. So I don't want to make you confused. Okay, no problem. Tomorrow we'll discuss remaining part regarding the routing. Our idea is first I'll finish ICMP and then we'll come back to the routing. That is the better part. Okay. So you can understand this particular things in depth.